Hi everyone, in this video we shall see the inventory models. First one, EOQ model with uniform demand. The objective of the model is to determine an optimum EOQ such that the total inventory cost is minimum. Few assumptions are made for this model. Those are demand D is constant and known, replenishment is instantaneous, that is the entire order quantity Q is received at one time as soon as the order is released. Lead time is 0. Purchase price or cost price per unit is constant. That is discounts are not allowed. Next one is carrying cost or ordering cost are known and constant. Shortage is not allowed. Next model, economic order quantity with different rates of demands in different cycles. Here the stock will vanish at different times of period with the policy of ordering same quantity for replenishment of inventory. Here replenishment rate is infinite, replenishment is instantaneous and shortage is not allowed. Next model, economic order quantity when shortages are allowed. The assumptions made for this model is also same as model 1 except the case when shortages are allowed and shortages may occur regularly. Now let us see a problem. A commodity is to be supplied at a constant rate of rupees 200 units per day. Supplies for any amounts can be had at any required time, but each ordering cost is given as 50 rupees. Then holding cost for the commodity in inventory is rupees 2 per unit per day, while the delay in the supply of item induces a penalty of rupees 10 per day per delay of 1 day. We have to formulate the average cost function for this situation and find the optimal policy QT, where T is a reorder cycle period and Q is the inventory level after reorder. So we have to find the best policy if the penalty cost becomes infinite. So here it is given that R value is 200 units, C1 is 2, C3 is 50 and also C2 value is rupees 10 per unit per delay. So here EOQ formula is root of C1 plus C2 by C2 into root of 2 C3R divided by C1. By substituting the known values, that is the values of C1, C2, C3 as well as R value, by simplifying we have that is EOQ Q star value is 109.5 units. So here next we have to find T naught. What is the formula for T naught? Root of C1 plus C2 by C2 into root of 2 C3 divided by C1 R. By substituting all those values we have the simplified value of T naught is 0.547. Now when C2 tends to infinity, that's what given in question, then we have the Q star value is root of 2 C3R by C1, that is 100 units. Now let us see one more problem. A manufacturer has a supply for his customer with 600 units, that is R value is given as 600 units. Then shortages are not allowed and shortage cost amount to 60 pice per unit per year, that is C1 value is given as 0.60. Then the setup cost is rupees 80. It means C3 value is given as 80. Find economic order quantity. Then we have to find the minimum average yearly cost, that is C0 value. And we have to find the optimum number of orders per year, that is N value. And the optimum period of supply per optimum order, that is we have to find the time, that is T0 value. So given values are R equal to 600, C1 value is 0.60, C3 value is 80. So EOQ formula is Q star equal to root of 2 C3R divided by C1. By substituting the values we have EOQ value is 400 units per year. Second one, the minimum average yearly cost, that is C0 formula is root of 2 C3 C1R. By substituting the values we have C0 value is 240. Third one is to find the optimum number of orders, that is N value is demand by EOQ which is equal to 3 by 2. Next, last one is optimum period of supply, that is time between two consecutive orders. That means T0 is root of 2C3 divided by C1R. We have T0 value is 2 by 3 of a year. Let us see one more problem. A company uses orders for a new machine after a certain fixed time. It is observed that one of the parts of the machine is very expensive if it is ordered without a machine. So here the cost of spare parts when ordered without the machine. We have the cost for spare part when ordered with the machine is rupees 500. The cost of downtime of the machine and the cost of arranging the new parts is rupees 10,000. From the past record, the probability values are also given. We have to find the optimum period of replacement of the spare parts. So here demand as well as the probability values are given. So from this demand, the cumulative probability has been calculated as 0.90, 0.95, 0.97, 98, 0.99 and 1. Now let us find C2 by C1 plus C2. The value has been found as 0.952. So from this we can say that the optimum number of spare parts to be ordered is 2. Thank you.